Okay, as promised, I told you I would come back and talk to you about Pythagorean triples, which is simply a set of three positive integers such that ABC, or should I say the integers are ABC, such that a squared plus b squared will equal to c squared. Let's take a look at an example of the very first Pythagorean triple, or the smallest actually, which is 3, 4, 5. And to prove that it is correct, we will use 3 squared plus 4 squared will equal to 5 squared. Again, 3, 4, A, B, and C, which is substituted for 3, 4, and 5. As we square 3, we'll get 9. Squaring 4, we'll get 16. And of course, 9 plus 16 is 25, so 25 equals 25. So these triples do equate like a Pythagorean relationship. Okay, I have for you a list of the first few. And may I say that there are infinitely many, but for the first few. And these I think are useful if we're looking, and I'm not saying not to literally do your work, but what I'm saying, if you're looking at a square with a side of 3, a leg of 3 and a leg of 4, then with knowledge of these Pythagorean triple, we would identify the hypotenuse as 5. Or let's say if we had a leg of 5 and an hypotenuse of 13, knowing the triples, we would automatically know that that second leg would be 12. So anyway, it's just an easy way for you to work with the Pythagorean theorem. Now, let me say the simplest way to create further Pythagorean triples is to scale up a set of triples. So, for instance, if we looked at 3, 4, and 5, and we scaled it by 2, which means we're going to multiply 3 by 2, we're going to multiply 4 by 2, and we're going to multiply 5 by 2, then we'll come up with another triple, which is 6, 8, and 10. Okay, we always want to prove or verify, so we can square 6 to get 36, square 8 to get 64, and 10 to get 100, and then we know 36 plus 64 give us 100, so 100 equals 100. It is a Pythagorean triple / relationship. We can also check with the second Pythagorean triple, which is 5, 12, and 13. Scale 5 by 2, there's 10. Scale 12 by 2, and of course it's 24. And if we scale 13 by 2, we get 26. Squaring 10, we'll get 100. Squaring 24, we'll get 576. And then, of course, 576 plus 100 gives us 676. Okay, I see a little something look like this is saying not equal to, so I'm going to just go ahead and change that to make sure that don't look like a fallacy to us here. Okay, so of course 676 equals to 676. So that's literally what these triples are about. What I will do is I will take the next video and come back and show you how Euclid, which is the father of geometry, used a theory to prove that these triples do exist. All right, have fun, Pythagorean triples.